Okay, so solving these forced second order differential equations is very similar to what we did last class. The difference is that the forcing functions are now sinusoidal. We didn't do any examples last class with sinusoidal forcing functions, but the general approach remains the same. Start by solving the homogeneous differential equation. Y double prime plus 2y prime plus 10y equals 0. The characteristic equation will be s squared plus 2s plus 10 equals 0. And that would factor to s. Right, this actually does not factor. So I need to solve for s using the quadratic formula. So s is going to be negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And that comes out to be negative 2 plus or minus 4 minus 40 is negative 36, so that's 6i over 2, which is negative 1 plus or minus 3i. Okay, so I have complex eigenvalues. This is a good opportunity to remind ourselves how to deal with that. So we can write out our solution y complex, right? Just use the same rules I do before, except it's going to be a complex solution. And it looks like e to the lambda t. So it's going to be e to the negative 1 plus 3i t. And again, you only need one of the eigenvalues because this complex solution is going to break down into a real part and an imaginary part. And each of those parts are themselves solutions. So that will get me my two real solutions to help me find y homogeneous. Okay, so now I'm just going to do a little algebra here. I'm going to distribute the t, and I get e to the negative t plus, times, no, I'm going to do plus right now, plus I 3t. And then I'm going to rewrite that as e to the negative t times e to the I 3t. And this becomes e to the negative t times, this is e to the I theta, so theta is really like my 3t, so this becomes cosine 3t plus I sine 3t. Distribute my e to the negative t, so I get e to the negative t cosine 3t plus I e to the negative t sine 3t. This is my real solution, and this without the I is the imaginary part. And both of those are solutions themselves. So it only takes two particular solutions to write down a general solution. So my y homogeneous is going to be k1 real plus k2 imaginary. The real solution is e to the negative t cosine 3t plus k2 times the imaginary solution, which is e to the negative t sine 3t. So there's y homogeneous. I'm going to go to a new page and see if I can find a y particular. Okay, I've rewritten the original differential equation. On the previous slide, we came up with y homogeneous. Now we're trying to come up with y particular. So my y particular is a guess. It has to have the format of the forcing function with an unknown coefficient, so a cosine 2t, plus any of its derivatives. So the derivative of cosine is sine, so I'm going to do plus b sine 2t. I don't need to do any more derivatives because the next derivative, the second derivative of 4 cosine 2t would be another cosine term, and it could combine with the a cosine 2t. So I just need the sine in the cosine term. So now I have to figure out y particular prime and double prime, plug in, solve for a and b. So the derivative of cosine is negative sine. And then I've also got the chain rule here. So this is going to be negative 2a sine 2t. The derivative of sine is cosine. So this is going to be plus 2b cosine 2t. And then y particular double prime, the derivative of the derivative. The derivative of sine is cosine, plus the chain rule means I have negative 4a cosine 2t. The derivative of cosine is negative sine, and I also have to do with the chain rule, so I'm going to have negative 4b sine 2t. So I've got y prime, y double prime. I'm going to plug them all into the original differential equation. So y double prime is negative 4a cosine 2t minus 4b sine 2t plus 2y prime. So I'm going to plug in this equation for y prime. Negative 2a sine 2t plus 2b cosine 2t. And then plus 10y. I'm running out of room, so I'm going to go to the next line. Plus 10y is a cosine 2t plus b sine 2t. And that's all supposed to equal 4 cosine 2t. So now this is just a matter of distributing, combining like terms, and equating coefficients. So I'm just going to distribute in this next step. I have negative 4a cosine 2t minus 4b sine 2t minus 4a sine 2t plus 4b cosine 2t plus 10a cosine 2t plus 10b sine 2t equals 4 cosine 2t. Okay, like terms are going to be cosines. So I want to combine all my cosine 2t terms. So I've got this one, and this one. So negative 4a plus 4b plus 10a. So the negative 4a and the 10a make 6a. So I have 6a plus 4b's all times cosine 2t. All right, then I'm going to do my sine terms. I've got this one, and this one. Negative 4b minus 4a plus 10b. So so I have a minus 4a, and then minus 4b plus 10b is plus 6b, all times sine 2t, and that has to equal 4 cosine 2t plus 0 sine 2t's. So I'm adding a sine term so that I can equate the coefficients of the cosine and the coefficients on the sines. So for this equation to be true, the coefficient on the cosine on the right is a 4. That has to equal the coefficient on the cosine on the left, 6a plus 4b. So 6a plus 4b has to be 4. And then the coefficient on the sine on the right is a 0. That has to equal the coefficient on the sine on the left. So it has to be that negative 4a plus 6b equals 0. And now I can solve this system of equations with two unknowns. All right, so I think I'll just solve 6b equals 4a and divide by 6. So b equals 2/3 a. go over to my other equation, and I've got 6a plus 4 times 2/3 a equals 4. So 6a plus 8/3 a equals 4. So 6, that is 18/3. So that's 26/3. So 26a equals 12. That means that a is 12 over 26, which reduces to 6/13, which means that b, 2/3 times 6/13. Let's see, 6 over 3 is 2, so that's 4/13. Okay, so I've got my y particular. It is this equation, but I'm going to replace the a with a 6/13 and a b with the 4/13. So y particular is 6/13 cosine 2t plus 4/13 sine 2t. All right, so I'm not quite done, right? I found y homogeneous on the previous slide. This is y particular. Y general is the sum of y homogeneous and y particular. So I'm going to need one more page. Just going to write it above this. Okay, so y general is k1 e to the negative t cosine 3t. This is y homogeneous that I found a couple slides ago, plus k2 e to the negative t sine 3t. It's y homogeneous, plus y particular, which we just found was 6/13 cosine 2t plus 4/13 sine 2t. Okay, so if I want to find the particular solution that satisfies y of 0 equals y prime of 0 equals 0, I'm going to start by plugging 0 into y general. Replace every t in y general with a 0. And I get y of 0 is going to be k1. Cosine of 0 is 1. And then plus k2 sine of 0 is 0, so that term goes away. Then I have 6/13 cosine of 0. Cosine of 0 is 1, so I can put 6/13 here. Plus 4/13 times the sine of 0, and the sine of 0 is 0. So k1 plus 6/13 has to equal 0, which means k1 is negative 6/13. And then to get k2, I need y prime. So I'm going to have to take the derivative of y. The derivative of y general, which is going to involve the product rule. Blech. Okay. First times the derivative of the second. The derivative of cosine is negative sine, and the chain rule, I get negative 3 sine 3t. Okay, so that's first times the derivative of the second plus the second cosine 3t times the derivative of the first, which is negative k1 e to the negative t, plus. Okay, so that was the derivative of that term. Now I'm working on the derivative of this term, which again, I'm going to have to use the product rule. So I have first k2 e to the negative t times the derivative of the second, which is 3 cosine 3t, plus the second sine 3t times the derivative of the first, negative k2 e to the negative t. Okay, that finishes the derivative of that term. Now the derivative of this term and this term are not product rules, thankfully. So this is just, the derivative of cosine is negative sine. And then the chain rule means that's going to be minus 12/13 sine 2t. And the derivative of sine is cosine, so this is going to be plus 8/13 cosine 2t. All right, so that's y prime. Y prime of 0 means I'm going to put in a 0 for every single t I see. When I put in a 0 for this t, the sine of 0 is 0, which means this whole term goes away. In the next term, the cosine of 0 is 1, so this becomes negative k1 plus, next term, cosine of 0 is 1, 1 times 3 is 3, so I get 3k2 because e to the 0 is 1. And then my next term, I'm going to make that t a 0. I'm going to get the sine of 0, which is 0, so that whole term goes away. This whole term goes away because the sine of 0 is 0. And then I get plus 8/13. And that all is supposed to equal 0. And I know k1 already. k1 is negative 6/13. So I have negative k1, so 6/13 plus 3k2 plus 8/13 equals 0. So 8 and 6 is 14, 14/13. So 3k2 equals negative 14/13. Divide both sides by 3, and you get k2 is going to be negative 14 over 39. Okay, so my y particular that satisfies y of 0 equals y prime of 0 equals 0 is just y general, this equation, but I'm going to erase the k1 and the k2 and replace them with this number and this number. And it won't let me do that. Okay. There we go. Okay, so k1 turned out was negative 6/13. And k2 is negative 14 over 39. And then that is that's not general anymore. It is just the solution.